watch, okay? So now we've successfully added that additional transform, which is doing the aggregate. What we want to do is now write that out to a table within BigQuery. So we need to create a new component, a new sync, which will be a PJDBC. Okay, and then we can go and enter in all the values for the PJDBC. Now, I've actually done this. So what I'm going to show you here is how we can actually take a component which has been created in a previous data pipeline and place it in the data pipeline that we're working on currently. So let me go and find that component that I want to copy. Here we go. Right, let's copy that. So once I've copied it, all I need to do is drop it into the playbooks folder for my current data pipeline that I'm generating. So that's this folder. Let's drop it in there. So that's now in there. I then go back to my designer window. And what I have to do in order for it to be placed on the screen is to reload this project. So if I go back to config, project run parameters, and then if I go to load, it'll pull up the parameters for the current project, which is fine because I want to reload that. Click on load. It says, are you sure you want to clear everything and reload? Yes, I am. And as you can see, it's now added a new component at the bottom here. Great. So what I will do now is go through the various key value pairs for a PJDBC. So first of all, what is PJDBC? So for IOblend, this is our capability to write to any database which has a JDBC connection. So that means we can pretty much write to any database. Like all the other components, there are a number of key value pairs and key value pair groups that need to be populated in order for the IOblend engine to understand how to actually convert this data pipeline into code and populate your desired database. So the first set of key value pair groups that we need to look at is the database design. And this is quite straightforward. So the first thing it's asking for is enter the driver. So every JDBC will have a JDBC driver. So you enter the JDBC driver name that you'll be using. Second is the fully qualified URL for that particular JDBC that you're connecting to. So that will also have information about the schema, the database, and also the security components to it. The next is you enter the fully qualified name for the table that you want to access. Also the name that you want to create. And then the next is metadata fields, whether you want to include them. So IOblend will manage your tables for you. So that means it will create your tables for you, it will manage them, it will add any primary key, foreign key constraints if they're applicable to that particular database. It will also do data lineage, and it will also do slowly changing dimension. So if you want to do any of those above, so in particular, if you want to have record level data lineage, and you also want to do slowly changing dimensions, then you have to include the meta field or the metadata fields that IOblend automatically generates for all of its components in the output. And what that means is if you click on true, then it will then automatically create the table for you. It'll create the appropriate view sitting on top of it, which will allow you to do record level data lineage or full data lineage. So you can either access the current record, or you can look at all the historical records for a record which has changed. And also it will create the appropriate table and views for the table for slowly changing dimensions. We'll go into that a little bit more detail in subsequent videos, but that's just an overview of what include metadata fields does and how IOblend will automatically create all of those components for you in terms of data lineage and slowly changing dimension. Write batch size, you can specify if this is set to 0, it will write everything all at once. The way PJDBC works is it generates a multitude of processes which will execute subtasks. So if I've got 100,000 records that I'm trying to write out, then IOblend will then split that write of those 100,000 records out across a number of processes which we can define. The right batch size is we can specify the number of records that we actually want to push out to each one of the sub-processors. If we leave it at 0, then it means that IOblend engine will just calculate and distribute that data across those processors as it sees fit. So we'll leave it as 0 and let IOblend engine work that out itself. Create options. So if we hover over this, it gives us an example. As I said, this will create the table for us, and it will generate a create statement, which is based upon the JDBC SQL template, which we'll go into a little bit later. What we can also do is we can add additional create options to that table. So if we wanted to add partition options, which are specific to that database or database make, then we can add them here. And IOblend will take those options, tag them onto the create statement. So when it creates a table, it'll be created with those options as well. Add jar class path. So typically, obviously, your JDBC will come with a JDBC jar. So what you can do is you can add absolute path to that JDBC jar. However, typically, you will always have that jar built into the environment, your IOblend engine environment, and the class path within your IOblend environment, IOblend engine environment will be set accordingly. So really, there's no need to do that. So we can leave that blank if we want to. IOblend maintained is the next set of group key value pairs. And this comes back to what I mentioned earlier and is related to the IOblend meta fields. So as I said, if we wish, IOblend can manage the creation of our tables and maintain them for us, as well as creating the appropriate database assets for data lineage and also slowly changing dimensions. So if we want it to do that, then we have to set is maintained to true. If we want it to create the entities for us, then obviously we have to set that to true as well. For the table which is being created, define what the primary key is. So actually the primary key for this one is actually the device ID. Obviously things like BigQuery doesn't recognize the primary keys in essence, so this just represents the unique key. So IOblend knows how to partition out the data. Column format. So one of the things we can do is any of the data which has been generated, for example, in this transform that we want to change the format for, there are two ways of doing that. Either we can create another transform, which then does a SQL cast on each one of those columns that we want to change data type to, or actually we can just do it in the sink itself. So with PJDBC, we can actually specify the format. So that's the data type of each column that we want to change, and IOblend will automatically change that for us. So for example, if I wanted to, I could put device ID, and then comma, and then the data type that I want it to be converted to. So in this case, it would just be int. Event keys. So these are the key or set of keys which uniquely allow us or allow IOblend to understand when a change has happened to that data in terms of versioning. In this instance, the key is just created date, so we'll leave that as is. Okay, so the next set. So the next set of key value pair grouping is referential integrity. So in this case, obviously BigQuery doesn't support that, so therefore we can leave that as blank. However, if it was something like Oracle that we were writing out to, then obviously you can set your foreign keys and your primary keys, and it will automatically generate that for you. Slowly changing dimensions. So as mentioned before, if we're asking IOblend to maintain this table for us, not only will it do data lineage, but it will also do slowly changing. So we'll create entities or assets in the background, which will do slowly changing dimensions type 2. So we will have a full history of any changes to every single record, as well as being able to just pull back the latest one as well. So in this instance, so you've got to enter in, first of all, set true to SCD, saying yes, you actually do want to allow IOblend to create a slowly changing asset for you. Then specify the key that it will use. In this case, I've used device ID. So this is the primary key for the record. So it identifies what is the unique record that it's trying to do an SCD against. And then the from key, which is basically a time value stamp or time column, which allows it to identify when there's versions or when a version's changed. So for this particular table, it's device ID and created date, which is based upon the output I'll be pulling from the component trans aggregate sensor. Okay, dependencies obviously at the moment it's linked to itself, so that's fine. And lastly, the display options. Okay, the debug options, sorry. Okay, so that all looks good. So what I need to do now is just create a dependency between my trans ag sensor and my new JDBC component. So let's do that. Okay, and we also need to change the run order of it as well. So we want it to happen after we populated trans. So that means the run order needs to be 7. Okay. And actually, because I've run this in a previous demo, let's change the name. So it creates a new entity. So let's call it version 3. And let's just make sure that that doesn't exist. So let's go off to BigQuery. Okay, so let's have a look at the tables which exist. And the one we're trying to create, which is version 3, doesn't exist. So that's good. So let's go back. Okay, so that looks all good. Let's now save the data pipeline.